This is the Big Bang, and this is how many scientists believe our universe began. Since the Hubble Space Telescope was launched, one of its most important uses has been to serve as a time machine, allowing astronomers to look back to the beginnings of time. Light may travel through space at a speed faster than anybody can imagine, but it is still a finite speed. Light from very distant stars is therefore very old, and because it is in space, Hubble can much better detect faint and distant light sources. These will show how things were when light began its journey billions of years ago. One of the key questions astronomers have wanted to answer for decades is how old and big our universe is. Hubble was built to answer this question. Since the Big Bang, when time began, the universe has been expanding. The rate of the expansion, called the Hubble constant, holds the key to determining the age and the size of the universe. By running the expansion back like a film until everything is compressed into that small point from which the universe emerged, its age and size can be estimated. But how can you get images from a film that has been running for billions of years? To determine the age of the light sources Hubble sees, astronomers look for remote, accurate standard candles, a special class of variable stars called Cepheids. Their stable and predictable variations tell astronomers exactly how far away they are. In this way, they serve as reliable comparisons for nearby supernovae, which are much brighter than the Cepheids and can be seen at far greater distances. Hubble has measured the light from Cepheids and ancient supernova explosions with the highest accuracy so far. And today, we therefore know the age of the universe better than ever before, around 14 billion years. An astonishing discovery Hubble has made is that the expansion rate of our universe has changed with time. When astronomers observed the most distant supernova, they found that these stars are dimmer than they should be. This implies that they must be farther away than predicted. Most astronomers believe this is a signature that the universe is accelerating its expansion and galaxies are getting away from one another more and more rapidly. Hubble also gave us the most detailed view of what our universe actually looked like when it was younger. Just as geologists dig deeper underground to find ancient fossils, so astronomers venture deeper and deeper towards the beginning of time, looking for light coming from the faintest and most distant objects. In 1995, Hubble was pointed to the same place in the sky for 10 days in a row. The first so-called deep field observation copied the technique of time-lapse photographers who keep their camera shutter open to capture faint details. The observation revealed thousands of previously unknown galaxies of various sizes, shapes, and colors. Besides the classical spiral and elliptical shaped galaxies, there is a variety of other galaxy shapes and colors that gave important clues to understanding the evolution of the universe. One of the most stunning results is the discovery that most stars formed a few billion years after the birth of the universe. The flamboyant aviator Wild Post proved the first real pressure suit when he flew his plane, the Winnie Mae, on a series of high-altitude flights in 1935. Years later, many suits for space evolved based on Post's design. There were even designs that never made it. This lunar model was developed at a time when it was uncertain whether the moon's surface could support a person's weight. Our first spacesuits were direct adaptations from Navy and Air Force high-altitude pressure garments. John Glenn, America's first astronaut to orbit the Earth, wore one of these during the flight of Friendship 7 in 1962. Later, astronaut Ed White made history as America's first spacewalker.
where for the first time the suits had to withstand the vacuum of space outside the capsule and protect the astronaut from extreme temperatures and micrometeorites. To land astronauts on the moon, a different set of functions was required. A full range of physical movement was necessary to carry out exploration of the moon's surface. These suits were custom-made. Each seam was tailored by hand. Gloves were molded from the hands of the astronauts. Cooling was provided by a liquid-cooled undergarment. The suit consisted of a pressure barrier and multiple layers of thermal, micrometeorite, and abrasion-resistant material. The shuttle required yet another spacesuit concept. The modular design can be converted to fit any astronaut. Today, there is much work underway at the Johnson Space Center, testing a zero pre-breathe suit, or ZPS, targeted for use on the space station. In the underwater test facility that simulates space conditions, astronaut Jerry Ross helps evaluate new suit components whilst practicing the assembly of space station structures.
I got any more cooling left?
This prototype suit eliminates the extensive onboard preparation required before working in space with the current shuttle suit. Not only will this be more efficient, but the savings in time will allow the astronauts to respond to emergencies immediately. There are trade-offs. The pressure in the ZPS suit is approximately twice that than the space shuttle suit. Increased pressure is harder to design for because the suit has to be sturdier. Joints need to be engineered so there is minimal resistance to movement. Across the country, another spacesuit designer at NASA's Ames Research Center in California is working on a suit that may someday see application on the space station. Vic Vicchiore has devoted a major part of his career to working on hard spacesuit technology. The suit can be entered from the rear and is built entirely of aluminium, a good material for space. It shields well against radiation and will hold up to the daily rigors of the space station.
This mission to the International Space Station had returned to Earth after successfully delivering a new lifeboat to the station and making history by taking the first African into space. The cosmopolitan crew of the Marco Polo flight comprised an Italian astronaut, a Russian mission commander, and South African businessman Mark Shuttleworth, who had paid some $20 million for his participation in the flight. The three-strong crew had thundered into the midday skies with a perfect liftoff from the wide-open plains of Kazakhstan. The perfect docking with the ISS took place in the morning, followed 90 minutes later by the ingress into the station and a warm welcome by the resident crew. One of the crew, Vittori, a trained military test pilot, described life on board the station with the Expedition 4 crew. He said it's clear that changing the crew from 3 to 6 with the actual configuration of the station was not an easy task with the resources on board that are very limited. During their 10 days in space, the Marco Polo crew attracted considerable interest. Vittori was the third European astronaut to visit the space station, and during his 8-day stay was overseeing the 4 European scientific experiments of the Marco Polo mission. Sponsored by the Italian Space Agency, the experiments ranged from studying the effects of cosmic particles on humans in space to more commercial experiments that assessed newly developed clothing. One experiment, Chiro, seen here, was designed to understand the forces and pressures involved by astronauts as they used their arms to move around in microgravity. After 10 days in orbit, the taxi crew safely descended to Earth in a Soyuz capsule with a textbook landing on the plains of Kazakhstan. These last few moments were described by the still visibly excited Mark Shuttleworth, the second space tourist and first African to visit the ISS, by saying, "It was all very sudden and very dramatic. I didn't know what to expect." They told us when we were at 1 kilometre, 500 metres, 300 metres, and then just before the impact, so we would know when to brace. But still, the landing was very unexpected and very hard when it hit. Following their exciting return to Earth, the crew enjoyed their first meal, a little more sedate than the fun of eating in space. This meal and the final ceremonies marked the end to a successful 10-day mission. Marco Polo was another in a series of European manned missions to the International Space Station.
Radiation exists all around us. In benign forms like microwaves or radio waves. Seen here, shrinking throat tissue. It's also used in therapeutic but potentially lethal forms like X-rays and radiation that kills tumours. But radiation exposure is not limited to Earth. Cosmic radiation is a major concern for astronauts in outer space. Scientists worry that the major long-term risks associated with radiation exposure during prolonged space missions could be radiation-induced cancers that probably wouldn't appear until later in life. As a result, NASA is trying to redesign spacecraft that could shield astronauts from radiation. The scientists are looking into chemopreventatives like antioxidants, vitamin E and C, as well as soybean extract that could help prevent the damage resulting from ionizing radiation. Those treatments will be especially important for missions to Mars and beyond.
Shuttle launches always make a compelling sight. However, on this trip, the payload was something rather unusual. It consisted of microorganisms otherwise known as jellyfish and was sent up by NASA to help learn more about living in space. Although it looks easy floating around, living in space certainly has its problems. Before humans travelled into space, animals were sent. When the first animal space travellers returned to Earth in good health, they brought back enough information to safely send astronauts into space. But even when NASA sent John Glenn into space to orbit the Earth in 1962, they still weren't exactly sure how his body would react. On Earth, we feel the effects of gravity almost everywhere, but you can experience a similar environment to space by going underwater. Unfortunately, you can't stay underwater for long periods of time. Microgravity can be experienced on a roller coaster ride or in one of NASA's special aircraft used to simulate it. But these only last 15 to 20 seconds at a time. The beauty of the first US space station Skylab was the ability to study living organisms in zero gravity. Dr. Dorothy Spangenberg is the expert that made these experiments happen. She had been looking at jellyfish and had noted their similarities to humans. Dr. Spangenberg and her students had worked with jellyfish for nearly 30 years before the opportunity of sending them into space presented itself. Jellyfish are among the simplest organisms, but they have neurons or nerve cells similar to humans. They have sensors called gravity receptors located in their arms. These help them maintain their balance and know where they are going, like a built-in compass. The gravity receptors tell them which way is up or down. We also have them in our inner ear. They help us maintain our balance. After riding on an amusement park ride, you feel like you are going to fall down. That's because the motion affects your inner ear. Even after you stop, the fluids in your inner ear keep moving. This effect makes you dizzy. This type of motion sickness also affects astronauts in space. By learning more about the development and function of gravity receptors, scientists hope to be able to fight the effects of space sickness. By sending jellyfish up into space, they wanted to find out if they would react differently in microgravity. Would they still know what is up and what is down? By the time the shuttle had settled into orbit, the jellyfish had passed their first test, proving that a microorganism can withstand the forces of liftoff. To help the jellyfish develop into Ephra, the first stage of development, the iodine mixture was added to another group of jellyfish. And while the experiments were being conducted on the orbiter, simultaneous experiments were conducted on the ground. Both groups of jellyfish were videotaped as they swam, in the hope of recording any changes in their movement or behavior. One of the most exciting changes happened almost straight away. Remember how the jellyfish used their arms to pulse up and float down to feed on Earth? In microgravity, the jellyfish moved in circles, but they were still able to pulse and swim easily. In fact, despite being in a microgravity environment, the jellyfish polyps developed normally. After 9 days in orbit, they began to prepare the jellyfish for the trip home. One group was secured in the locker to be immediately studied after landing. The second group was preserved in a special liquid to be studied and compared to the jellyfish used in the simultaneous Earth experiments. Scientists spent more than a year studying the microgravity jellyfish and comparing them to the Earthbound group. The results surprised everyone. After swimming in circles in space, some of the jellyfish swam a little differently on Earth. However, most of them adapted to their normal behavior patterns pretty quickly. Scientists believe that their gravity receptors behave differently, which made them more sensitive to microgravity. These experiments will result in more knowledge about human cells, our basic unit of life, and how they develop.
Scientists have said the Etna volcano has the same atmospheric and surface conditions as Mars and gives them the best opportunity to test out probes that will eventually end up on the planet. Etna is no stranger to robots and has the RoboVol at the ready to take samples from the surface lava should it erupt again. The equipment being tested took samples from the ground and the atmosphere on the north face of Etna. Robots like the Walkie 6 are being used to film the surface of Etna. While this is just a prototype, scientists hope that the robots will eventually help them to understand more about Mars and find out whether or not there are conditions for life out there. The aim is to make a machine with legs adapted to explore Mars, asteroids, comets, or other surface with low gravity. The legs should help the robots navigate the rocky surface of Mars when they arrive. The prototypes are the result of a joint project by the Italian, European and German space agencies, along with Turin Polytechnic. The data they pick up will be analysed by an onboard computer and sent back to Earth for further processing. Although wholly European by design, the Etna robots should be used in NASA's mission to Mars instead. According to Eduardo Rey, who came to the test site from Milan, it is the first time they've used a test site like this, where the conditions are thought to be like that of the planet Mars. This is not the first time robots have landed on Etna to test the volcano, but it is the first time that these same robots will go to Mars. Space. Is it the final frontier? Or could it be the key to answering some of our common medical questions here on Earth? Researchers at the Mount Sinai School of Medicine in New York believe the clues are everywhere. Just look up. A neurologist has been involved with space research to unlock potential treatments for balance problems. The human centrifuge, sort of like a one-person carnival ride, is used to spin astronauts at zero gravity and measure their eye movements. The way they lean and focus their eyes can reveal information about human spatial orientation. According to the researchers, with this simple mechanism, the team will be able to learn more about motion sickness, dizziness, and poor balance. The same study is also looking at bone loss in space. Elderly here on Earth suffer the same amount of bone loss at the same rate as astronauts who are at risk due to zero gravity. For a 3-month spaceflight, astronauts could lose 15 to 30% of bone mass. Everyone understands that if you don't use your muscles, they atrophy. Not as many know that bone also has its own kind of atrophy. Basically, if you don't use it, you lose it.